Hello. In this video, we were going to go over using StatCrunch to find correlation coefficients and regression lines. The first thing that you need to do is you need to load the data that you're going to find the correlation coefficient or linear regression for into StatCrunch. So you can load that from homework or by entering the data by hand. But you need to have the data in a StatCrunch spreadsheet before you can go through and actually do the calculations. Okay, so once you've got that data entered, then to go through and find the correlation coefficient or the linear regression equation, you're going to open the linear regression calculator. To do that, you're going to select stat at the top, then regression, then simple linear. And when you do that, the simple linear regression window is going to open. So once you have the window open, you need to go through and select which of the columns of data that you have is going to be the X variable and which of the columns is going to be the Y variable. So you go through and make those two selections and then press compute. So the compute is at the bottom of the page, so you can see the whole page here. So we've got the two variables and then compute down here. All right, so once you've done that, you're going to get your results page. So the results page is going to contain the correlation coefficient and it's going to contain the linear regression equation. So you can see the correlation coefficient is right there and the linear regression equation is right there. And that's it. That's all there is to it. So you just go ahead and hit stat, regression, simple linear, select the columns, compute, and boom, you've got your correlation coefficient and your linear regression equation. All right, and you can see the whole page here. All right, and so the other thing we're going to talk about here is briefly is the scatter plot. So you'll notice there's this arrow down here at the bottom. If you press on that arrow, it's going to actually go through and take the data and put it into a scatter plot along with the regression line. So you can see that here. All right, so we've got the plotted data and the regression line. So it's pretty cool, huh? All right, so let's go through some homework examples now. So we've got a table that shows the approximate distance between selected cities and the cost of flights between those cities. And we're asked to go through and find the correlation coefficient between the cost and the miles. All right, so we want to go ahead and load the data into StatCrunch. Then once we've done that, so the way to do that in the homework, of course, is just to click on this little button. Once we've done that, select stat, regression, simple linear, then put miles for the X, cost for the Y, and hit compute. What you're going to see is you're going to see the correlation coefficient is on the results page, and it's going to be 0.988. And you can see the result page is right here with, as I just said, 0.988. All right, that's it. All right, so another homework, yeah, these problems are pretty short. So another homework example. So we've got 5 people were asked how many female first cousins they had and how many male first cousins they had. So that data is here in the table, and it wants us to find the correlation coefficient. So again, load the data into StatCrunch. You can use that button. Select stat, regression, simple linear. So pick one of the variables. This time it doesn't matter. There isn't an obvious order to male and female here. And then go ahead and press compute. The correlation coefficient that you're going to get is going to be 0.834. And you can see that on the next page, 0.834 next to the correlation coefficient result. Okay, and then so moving on to, so that all of that was correlation coefficient homework. So that would have aligned with section 4.2. So the rest of the video, we're going to go over linear regression homework. So that's 4.3. So if you haven't watched 4.3 yet, you probably want to watch the 4.3 video first before watching the rest of this one. All right, so once you've done that, so we've got, they give us a table. A table gives the distance from Boston to reach other cities. So it looks like there's a little bit of a typo in that. All right, so but we've got from Boston to various cities and the ticket price cost that goes along with that. All right, so we're asked to go through and create a scatter plot and describe the association, compute R, the correlation coefficient, and write the equation for the regression line, interpret the slope of the regression line, interpret the y-intercept, again for the regression line, and then predict the ticket price to Milwaukee. All right, so it wants us to go through and do a prediction using our regression line. All right, so the first thing we want to do is to go ahead and create a scatter plot and describe the association. That's the first question. So to do that, load the data to StatCrunch, select stat, regression, simple linear, make the distance X, the ticket price Y, and then press compute. Go ahead and hit the right arrow so that you can generate the scatter plot. And so if you look at the scatter plot, you should see a strong increasing trend in the data. And so there it is. There's the scatter plot. We have the points are quite clustered reasonably close to the line. And so we do have a strong linear association here. Next, go ahead and find R and write the equation for the regression line. So to do that, you want to just press the back arrow on that last page, right? So if you look at that last page, you want to press that back arrow, and it will take you back to the previous page. And if you do that, the correlation coefficient is roughly 0.877, and the equation is that the ticket price is equal to 44.1 plus 0.2111 times the distance in miles. So unfortunately, I didn't save that result, so my apologies for that. But we just went over earlier in this video a couple times the results page, so you've seen it before. All right, next, go ahead and interpret the slope of the regression line. So the slope of the regression line was that 0.2111. So what is that? How do you interpret that? What does that mean? All right, it represents the price increase. All right, so it represents the increase to the thing that's over here on the left side of the equal sign for every increase over here. So it's the increase in Y for the increase in X. So it's the price increase, which is on the left side, which is 0.2111. So we're saying the price increase is 0.2111 per extra distance, per extra additional mile. All right, so that's how you interpret it. Okay, so again, it's the amount that this increases, so the slope right here is the amount that this increases per additional increase in this thing. So we get an extra 0.21111. Is there too many ones there? Anyway, we get that much increase for every additional mile, so 21 cents. Okay, so interpret the y-intercept. So the y-intercept is where the x value is 0. So if the x value in this case is the miles the two cities are apart. So if you go ahead and enter 0 for the miles, you're basically saying that, from Boston to a place that's 0 miles away, it doesn't really make sense. Okay, so sometimes the y-intercept makes sense. You can interpret in a way that seems useful, but in this case, it's not, the ticket price from Boston to Boston. It doesn't really make sense in this case. You wouldn't say, okay, well, there's a ticket that you can look at what that would be. It's this number right here. So it's 44.1, but it's not like you'd pay 44.1 to go 0 miles. So it doesn't really make sense in this case. All right, and then the last one is to go through and predict the ticket price to Milwaukee. So to predict the ticket price to Milwaukee, we start with our linear regression equation and plug in the distance, 858, and then we just solve for the price, and you get the ticket to Milwaukee would be $225.22. Okay, all right, so that's the last problem, the last part of that problem. All right, let's go on. Let's try another problem, right? So we've got this table shows the number of text messages sent and received by some people in one day. So just went through and collected some data that's incomplete. It does continue further down, but I couldn't go through and get any more of it to fit on this page. So the instructions are to create a scatter plot and state the sign of the slope, find the equation for the regression line, interpret the slope of the regression line, and interpret the y-intercept. All right, so the instructions are the same as we've done multiple times already. So load the data into StatCrunch, select stat, regression, simple linear, put sent for X, received for Y, and then press compute. All right, so press the right arrow at the bottom to generate the scatter plot, and then we can see the result on the next page. Wow, the points are they're right on the line. And you can also see that the slope of that line is positive, right? It goes up as you go from left to right. All right, so next, find the equation for the regression line. All right, so if you just hit the back arrow on that previous page, right, so you hit that back arrow, and it should take you back to the results page, and then you can see the linear regression equation, and what it has there is it has received equals 1.534 plus 1.020 times the cent. Okay, and then interpret the slope of the regression line. So as I kind of went over in quite intricate detail in the last one. So what is the slope? It's the amount that this increases per additional increase here. So if you send one more sent message, then your received message is going to go up by the slope. And so it's going to go up by 1.02 messages. All right. So for every additional sent message, you get 1.02 additional received messages. Okay. And then finally, we get to the y-intercept. So the y-intercept would be if we sent no messages. So if we sent no messages, so you put a 0 where the sent messages, you're still going to get 1.534 received messages, and we round that up to 2. All right. So if you send 0 messages, you still get 2 messages are received in the one day. Okay. And this time I did remember to put the results page. All right. So you can see it didn't ask us for the correlation coefficient, but there it is. Look at that, 0.9997. That's crazy high. And then you can see the received equals, whatever times the sent. Okay, and that's it. That's how to go through and use StatCrunch to find correlation coefficients and regression lines. Thank you for watching, and I'll see you next time. Bye.